Okay. So it already placed a lot of code here. So I'm just going to go through and explain what some of these are. So this is our main runoff mode method. They provided some comments here. This one is based off not a webcam, but the phone itself. So we're assuming that we're using the phone's back camera in this example as the mechanism for detecting Vuforia off modes. There's also another sample like off mode when you're about going through the blocks. There's another op mode also called concept Vuforia nav webcam. So you can use this one if you want to use your webcam instead of the phone camera. So you can see in the very beginning what they do is telemetry.add data initializing Vuforia. This will to the driver station print that Vuforia is being initialized. This is important because the Vuforia method can take a couple seconds, and you don't want to run the op mode without Vuforia being initialized because it might error out. So it takes a couple of seconds, and you want to make sure you're running this during the initialization phase of your op mode so that you can get it out of the way, and by the time you're ready to run your op mode, you can just run it without having to wait for Vuforia to init. So it's just a simple telemetry message that says initting Vuforia, and then it jumps down to this method init. This is one of the default blocks that FTC provides to initialize Vuforia. The camera direction refers to on the phone, whether it's the back camera of the phone or the front camera of the phone. And you can go with the default for the rest of them. Enable camera monitoring will allow you to see on the robot controller preview of the what the webcam or the actual camera is seeing. And the rest of these, if you leave them at 0, they will tell you it will essentially assume the phone is at the center of the robot. So for example, let's say your phone is if you look at this, you can notice that X is considered this direction, Y is considered this direction. So let's say that your phone relative to the robot is like on the front of the robot and it's 9 inches off of the center. You'd want to plug in on the X or the Y, depending on the orientation and rotation of the robot. You'd plug in 9 to represent that the phone, where the phone's location on the robot itself is. And then the orientation of the robot, they flip the Y around because because the back camera can be flipped over to the front camera because they're using the back camera as the main camera and the back camera is considered behind. So that code is all run during the initialization phase of Vuforia. So once that runs, it says Vuforia initialized. So the driver should, on the driver station, you have to wait for it to say Vuforia initialized and then press start. And that's how you initialize the main Vuforia code. Here, the if statement is just to make sure that they say op mode is active, just to make sure the user didn't press stop right after initializing the op mode. If they press stop, it'll skip the code and just not run anything. And then this is the main code that runs. So while the op mode is active, so this is a while loop, which means it constantly runs. As long as your user hasn't pressed the stop button, this code is going to continuously run. And you can see they have I believe this year there are 5 Vuforia markers. There's 2 on the goals themselves. There's 1 on the front wall, and then there's 2 for the called the alliance targets. So if any of those targets is visible, it's going to run a method called process target. Otherwise, it's just going to say no targets detected, targets aren't visible. So right when you start this off mode, if you're not looking at any specific target, it's just going to say no targets detected. And then this loop is going to continuously run. And I'll go through the details of what process targets do. But at the very end, they call Vuforia ultimate go.deactivate. This will shut down the Vuforia system and then disable the webcam or anything so it can perform a clean exit out of the off mode that is currently running. So before I let me start with this. This is a function created in blocks. It allows you to do unit conversions. So this is because Vuforia returns distances in its millimeters. So you have to make sure if you're plugging anything into Vuforia, you want to be dealing with millimeters. So when you're initializing the default variables, it should be done in millimeters. And when you're getting values from Vuforia, you're going to get them in millimeters. But if you would prefer to use a different unit, such as inches, you can use this method. You can see you have to pass in two variables. When you call this method, you have to pass in two variables, the original value and what unit you were trying to convert to. So let's say the original value is like 20 and then the units is centimeters. It's going to take that unit, if it figures out that the unit is centimeters, it will divide it by 10. So the converted value is from 20 millimeters, it goes down to 2 centimeters, and then it'll return that 2 centimeter value. So this is just a function to do unit conversions. So up here, I mentioned that if no targets are found, it just logs no targets detected and calls it. But if it can find any one of the 5 targets, it calls the process target method. And the process target method will find it'll take the Vuforia results variable, which it will show you like the details of the Vuforia target. And it will log the X, Y, and Z position of the robot, I believe, based on the results of Vuforia. So you can see it displays the name, and this displays the location of the target itself. So you can even use this simply to see if you're looking at, make sure that you're looking at the correct Vuforia target. So it will print the name of the target, one of the 5 names listed up here. So print red lines target, blue lines target, depending on which one the webcam is currently looking at. Vuforia will print out the name of the target and also the X, Y, and Z locations of the tracking results and the angle. So using that information, you can get the position of the Vuforia target itself and where it's located. And this is just like a fancy round decimal method, because sometimes Vuforia results returns data in different levels of precision. So if it says like 10.513 inches or something, the decimal values tend to vary. So this method will round it to 2 digits of precision. So I think it's 2 digits after the decimal. And using this, you can get the location of the targets.
The trackable names, those are, you invent those as like text?
If you use this op mode, all of these details, like all of these methods will be inbuilt. But inside, the trackable names are, I believe, default to this season's field. So if you look inside, I think they're variables that you would.
Right. So you assign those variable names, right?
Yeah.
And then another question, I keep seeing kind of, I guess it's more of a syntax question. You'll say call, for example, where you have it on the screen, call Vuforia op mode dot op mode is active. And I kind of took it for granted, but now I'm noticing it all over the place. So I'm trying to figure out what's that syntax mean when you have a dot and then something else, because down below you had dot add data. I'm trying to figure out, it seems like a pretty basic question.
Yeah, it's if you understand Java, it's a little bit blocks is like built around the Java code. So if you understand Java, I'd be easily be able to say it's like an op, it's like the class and the method. But essentially, here the Vuforia op mode is the name of the variable. So there's a couple important methods inside the FTC SDK that belong to the op mode itself. So when we say call, we're essentially calling a method on a variable. For example, there's a variable called telemetry, and it has a method called add data. So the telemetry is an object that allows you to like print stuff to the driver station. Add data is the name of the method. So telemetry is like the logging mechanism. So it's an object and then it's variable. So here, Vuforia op mode is the name of the variable, and then that variable like has a method inside it called wait for start.
So is there a way that you could figure out, like, is that, I assume that's what you mean when you say libraries, that it contains all of that in one location? Is there a way that you would, so for example, let's say that there's an op mode that you've never used before. Say you've never heard of Vuforia. Is there a way that I could reference something and say like, oh, look at all these op modes?
So the Vuforia does have a bunch of methods. Usually you can look through the drop-down menu and there's a lot of details. Like all the call methods are mostly going to be available within the drop-down. Here you can see, like if you forget a Vuforia trackable, there's a method called get, a method called set name. The Vuforia ultimate goal has an activate method, a deactivate method. All the call methods are available in the side drop-down section. And for example, the linear op modes, these are some of the basic call methods that belong to the op mode itself. You can see the wait for start here. That's where all of these wait for starts, op mode is active would come from, the op mode itself.
Got it. So one of the strengths of this blocks program, now I'm understanding, is that I don't even have to understand all of that. It kind of gives you the syntax automatically, so that I just have to select from the drop downs.
Yeah, the syntax comes naturally, and you can mouse over most of them to get details about them. Like this one says, is stop requested will tell you like if the op mode has been requested to be stopped, if someone asked for that op mode to be stopped, which happens like if someone presses stop on the driver station.
Okay, got it. So probably not using the words correctly. I know you're talking about classes and other stuff, but to me it's kind of in the old language of like kind of routines and subroutines.
The wait for start, these stuff on the right, you could consider a routine. The telemetry is like a variable, and the routine is inside the variable tag.
Okay. All right. Thanks a lot.
And these trackables are default FTC variables. They're not like custom named. Like I didn't create these names. FTC essentially has them in a list that you can use. You can find it inside the Vuforia trackable section, I believe. Optimized. So there's a list of trackable names, so you can refer to each target. And if you directly run this op mode, it will, I don't have a phone with me right now that can actually run this, but if you run this code, it will, and you point it at a Vuforia target, it will locate the target and give you details about it.
Those targets change every year though. So is that something that you have to kind of reset yourself? You're saying, I know the names themselves are, you're saying, is set by FTC, but what about the images? Because those change. Like, how does it recognize it?
Oh, that's why these names are like specifically every year they will change, like the trackable names will change. Also, like next year, for example, if you just recopy the sample op mode, if you update your application to the latest version and copy the Vuforia example that they give you, they update that every year to match up with the season and what's going on.
Got it.
So
Thanks.
all this code you came from that sample, and they will update that. And you can see here, these tabs on the left side, these are the bottom few are generic to every year. So if you look inside Vuforia Trackable, it asks you for the name of the variable because it's very generic and you can use it any year. The very top section, optimized for ultimate goal, is referring to this specific year and will change it every year. So the variables that have been created inside here are optimized specifically for this year's game, most of them. And there is a method, if I can delete this, and so these variables right here, it says Vuforia tracking results.y. So that will give you the X, Y, and Z. I think you can ignore the Y position because that represents the height, and the height of the targets don't really matter. Especially in robotics, we're only looking at the X and Z position on the field itself. Sorry, X and Y position. The Z represents the height, and you can mostly ignore that. But all of these variables right here will give you the position of the tracking object itself. If you want the position of the robot, there's a method called get updated robot position. And you can store that in a variable. So if I can find the telemetry. So along with the position of the tracker, you can do this. Oh, never mind. This is a variable. It needs to be stored in there. So you can store it as a variable, and that you can also use the so if you do this, for example, where you do Vuforia tracking results dot format as transform, that will take the results of the Vuforia tracking results and then convert it into a string that tells you the robot's current position. So you can use this data to get the exact position of the robot on the field. And then you can use it in a variety of scenarios. For example, you could have the robot moving in a straight line and continue to do that until it reaches a certain position, or like say even but one thing you have to keep in mind is that to get the robot's position, you have to be looking at one of the Vuforia targets. So if you can, in previous years, we had to think about how to write a op mode in a way that will have to look at one of the VU marks as it travels. So we try to make it look at a VU mark. Sometimes we even just run directly straight in the direction of a VU mark. And once it picks up the location of the VU mark, we can then identify where we need to go or what we need to do. So as it travels around the field, whenever it is able to see a Vuforia target, you can then use that data to figure out its own location. So do you guys have any questions?
Is there a way to marry up the robot position? So robot position, you said it returns back a string, right? What would that string look like? Would it be, it would just tell you what the target that it's looking at, or what would that string look like? Or whoops, I'm just talking.
It's okay.
I'm trying to figure out, is it coordinates, or does it tell you that, you know, you're in front of, you know, red target, or
I believe the the string itself is for logging. I'm trying to find the exact specification. I don't think I currently have it, but similar to how you can do X, I think you can do this. Never mind. Similar to how you can do Vuforia tracking result .xyz, you can you should be able to get the XYZ position of a Vuforia trackable.
So what would the, once Vuforia identifies where it is, what sort of data would it give back? What would it look like?
It's the X, Y, and Z position and orientation of the robot itself.
What is the orientation like in a 360-degree?
Yes, correct.
Okay.
0 to 360. Based on the image itself.
Okay.
It will calculate.
So like X is 0, or no? I guess Y would be 0. Why?
It should be 0. Sometimes, depending on where how the image looks, it might miscalculate it. But Y.
Can you?
Z is the height axis.
Sure. If you look at that that image you had before, the other one of the full field.
Let me pull it up.
I'm sorry.
Z refers to the
Sure.
height axis.
So I'm trying to imagine where 0 would be, because usually,
Oh, on the field itself?
yeah.
If I'm not mistaken, one corner of the field is considered 0, 0.
Okay.
Is there a way to like change where the origin is? Like where 0, 0 is? So can you like position in it at like one corner or in the center of the field, or is it always in one corner?
Yeah, I assumed it would be related to the initialization process. So like wherever you are upon initialization, perhaps that's origin.
No. The origin is based on the static field itself. It's in one corner of the field, and it doesn't like the origin of the field is always in one corner, and then the other corner is considered 72 inches, 72,72 inches for those. I believe the field is 72 inches by 72 inches, or yeah. So it doesn't, regardless of where the robot initializes, well, that's another advantage of Vuforia, is that it provides an absolute location of your robot on the field. So where you initialize will not impact where it thinks it is.
So somewhere in there, it's going to say X equals a value, Y equals a value, and an orientation value in degrees.
Yes, similar to the this X, Y, and Z, this is referring to the position of the tracker.
Right.
And there's a similar mechanism, I'm not exactly certain, but there's a similar mechanism to get it for the robot's position itself.
For the rotation, the compass rotation.
Yes.
So then can it also give your coordinates in polar coordinates, or is it merely rectangular? Like you're talking about how it gives like an angle.
The angle is 0 to 360 degrees. So it doesn't, so let me check. I don't think the initialization phase allows to change the radius. You can create a custom function to convert it into radians. Is that what you're referring to by polar measurements?
Polar coordinates, I was referring to, you know how it gives like
Like you're saying
how
instead
many
of
effort degrees and then how long that arc is, or
you're referring to the X and Z. I think that would have to be a manual conversion as well. Vuforia only gives the X, Y, and Z position on the field.
okay.
It's going to go tell it X and Y, and then it's going to tell you which way it's pointing.
Okay.
Yes. Oh, yeah. Yeah. The orientation is the robot's orientation on the field itself. Yeah.
We have to find that in the Vuforia instruction manual.
Yeah. I think I will also explain some of the TensorFlow. Again, let me start with the presentation. TensorFlow is a machine learning technology. By itself, it's a very general, you can find it on various devices. TensorFlow in general allows you to train and build models. And one of the most common tasks is to detect objects. So the first library already provides inbuilt utilities that allow you to data sets that they trained by taking a bunch of pictures of sky stones, or this year a bunch of rings. And then once you load that model into TensorFlow, which is I'll show you in the example, you can then identify the location of and the count of how many rings are like on the field, for example. So there is a similar sample for TensorFlow object detection. It also depends on Vuforia. So this initialization code we already saw before, but it's presented again. So TensorFlow does depend a bit on Vuforia. And you can use both of them at the same time. So you can get the robot's position, and you can also get the TensorFlow value. Here you can see the initialization phase. To initialize TensorFlow, there's a couple of variables in there. One of the more most important ones is the minimum confidence. You can tweak that variable. Essentially, every item that TensorFlow identifies, it gives it a confidence rating. So 0.7 would mean it's 70% confident that that ring is a ring and not just some yellow mistaken blob. So by setting a minimum confidence, you want to set it high enough so that it's not accidentally picking up something incorrectly as a ring, but it can't be too low or otherwise you'll miss actual ring targets because it's not confident enough. The enable camera monitoring, and the object tracker will mark on the camera where the exact rings are. And the enable camera monitoring will allow you to see on the robot controller where exactly the rings are and what TensorFlow is thinking and looking at. Here they also set a zoom. In this case, they're trying to crop it down because the ring stack is usually, depending on how the robot is positioned, the ring stack's in the middle of the webcam. So there's a zoom method this season that allows you to like zoom into the specific part of the field, so you don't have so the TensorFlow has less to look at and can focus on the specific ring stack target. And there's a similar op mode is active and structure. So we're just going to keep looping through this until the user presses stop. So there's a variable called get recognitions, and that will recognition in TensorFlow refers to an object. In this season, that refers to a ring. So recognitions is a list of rings, each one with plenty of like details on the X, Y, confidence, a bunch of details. So if the length of recognitions is 0, that means that no rings have been detected. So in this year's season, one of the goals is to detect how many rings are in the ring stack and run a different pathing movement if there's 0 rings, 1 ring, or 4 rings. So if their length of the recognitions is 0, then you can safely assert that like there's no rings on the field itself. Otherwise, they are running a for loop, so they're going through every single ring inside the list, and then calling this display info method. And at the very end, they deactivate the TensorFlow object to shut it down. So this code right here, they pass in a single variable called index. So they are logging each object with its with an index value, and they're logging each recognition. You can get there's a bunch of variables you can get inside there. The important ones are confidence. So you can see like how assertive. So Vuforia, TensorFlow might say 90% confident that this object is a ring, or so forth. So you can see, for example, if it incorrectly marks something as a ring, you might want to check if it says it's 40% confident that it's a ring, but it incorrectly is marking it as a ring. You might have to up the minimum confidence shown in the configuration above to a higher value or a lower value if it's not detecting rings. So that will have to be fine tweaked. And This merely uses telemetry to log the left and the top position of the recognition. So before, I mean, TensorFlow will draw a square box around where it thinks the VUMark is. This is last year's season, but you can see it's drawing a rectangular box around each target. So that code will return the top left value of each ring. So it gives you details about what it's seeing. But for this year's game, you can simply see how many recognitions there are, check the length of the recognitions. And if it's 0, run one code. If it's one ring, you can run the, you have to, depending on how many rings there are, you have to move the wobble goal into a different location. So you can use TensorFlow to detect how many rings there are and move the robot based on that. Again, any questions?
Can we look at that else loop real quick?
Sure.
You were so if it looks at the length of recognitions, it does 0. I see that you're setting the index there to see if there's 1, 2, 3, or 4, right? Something like that.
This index is, so when all this code right now does is it just logs the information. The reason we have an index is so that when we're logging the data, we can see ring number 0, like ring number 1, ring number 2, ring number 3. It will log it with the specific index of the ring itself. So that when it prints out the data, it will say ring 1 is located at this position. Ring 2 is located at this, but it's just a number counter.
Got it.
And we're passing it into the display info function. We're passing it in. So this method is going to get called 0, 1, 2, 3, 4. The I keeps incrementing.
Okay, so I guess what I'm trying to figure out is if you could scroll back up to that else loop, or a little bit higher. Yep. So it says if length of recognitions. The way that I was understanding it was that it would help you figure out based on the number of rings, which you know what actions to do after that, right?
Yes, you can structure the code like that. This is you can actually use this code similarly. So if the length of the recognitions is 0, you can here you would put the you could create a function where it says wobble. I'm gonna say I'm gonna call it wobble goal 0. But this could be like your algorithm for moving the robot to the first wobble goal place.
Right. So then the next else would be if length of recognitions equals 1, or I forgot what the options are for the
0, 1, or 4.
Right. So that would be basically your options, right? Your else, and give it different,
Yeah, you would use
functions.
Yeah, actually, I think I can. You can make it an if, else if in there. And then, yeah, else if the length of recognitions is equal to length of the recognitions variable is equal to 0, you can do the so if it's equal to 1, you would run your wobble goal 1 method, whatever logic you have to getting the wobble goal into the other thing. And then final case would be if the length of the thing is equal to 4.
And then I'm guessing you guys have already started kind of programming that. Are you using the visual cues? What do you call it? Vuforia to to guide your once you recognize how many rings that you have, are you using Vuforia to guide how you navigate, or are you using more like positions, like converting tick, you using the encoders?
This year we're actually using a system called Odometry. It's a little bit more advanced. I remember previous years we would try to use, if possible, motor encoders like ticks, and then depending on the situation, we try to use VUMarks as much as possible. Like we try to make it so that the robot like moves forward until it gets really close to the VUMark, or try to make the robot so it's like facing the VUMark so that we have like some position accuracy. For example, here you can see that we can like sort of see this VUMark near the goal. So we could have the robot move forward until it gets a certain distance away from the VUMark, so it gets close to the VUMark. And based on that, we can see like, we would try to use some sort of logic to say, if you get at least try to get 20 inches within this VUMark, keep moving forward until you get 20 inches near this VUMark, or something like that.